Okay, anyway, let's get started. So today we are going to a new unit, which is air pollution. And today we only have 4 topics. The first one I will briefly talk about air pollution, and then I will go through like the why do we care about it, and like the regulatory standards about these air pollutants. And finally, I will go through these air pollutants like one by one, so we can have some general ideas about these pollutants. And so first, atmosphere. So basically, atmosphere is a layer of gas or layer of gases that envelopes the planet and is held place by the gravity of the planetary body. So basically, we should know that the atmospheric composition includes nitrogen, oxygen, argon, and some carbon dioxide. It may also have some other components that may vary by time or by place. So in general, we can see that about 99% of the air consists of nitrogen or oxygen. And it has some ecological services, like it can block the UV radiation, so it can protect us, and it can also moderate the climate, and it can redistribute water in the hydraulic cycle. On the left side is the temperature profile of the atmosphere. We can see that the atmosphere can be classified into different layers. And the lowest one is troposphere, which is pretty related to ourselves. And from this figure, we can see that the y-axis refers to the altitude, like the height, and the x-axis is the temperature, but that is in K. But we can see that for the troposphere, we can see that the temperature is decreasing with height, which means the higher it will be colder. So what it tells us is that suppose we have the air that has a high temperature at the bottom. We know that the density is relatively smaller, so the air will going up because of the high temperature. So the air will go up, and then because it will take some space, so we may have some air that is going down. And so basically in troposphere, we have this vertical movement of the air, and this will help to transport the air pollutant. And so here shows the behavior of the plume. And so basically, this is a temperature, and this is a wind speed. So in general, when we are talking about the plume, that's the smoke from a stack, we may have some images, something like this. And in this case, so basically this dashed line refers to the temperature profile that it should be. But in reality, because of the time or some other factors, the real temperature may be different from the temperature profile. And in this case, the solid line refers to the real temperature profile. We can see this is pretty close to the temperature profile of atmosphere. And because of the vertical movement of the atmosphere, so the pollutants will be dispersed. And I'm going to talk about this more on Thursday. But we can also see that by having different types of temperature, like the real temperature profile, we may have the plume of different shapes. So I want to focus on this one because I think this is very common in our daily life. So in this case, we can see the temperature should be decreasing as this dashed line, but in reality, it's decreasing at some height, and then the temperature increase. So in this case, we may have a boundary like this. And under the boundary, we will have this convection, like the vertical movement of the air. On the other hand, in this region, because the colder air is at the bottom, and we know that the colder air is very happy to stay at the bottom. So in this region, it is very stable. So there is very small amount of vertical movement of the air. So this is stable and this is unstable. And we can see, so this is a plume. And this boundary refers to this boundary. We can say because the air is very stable in this region, so the plume or the pollutant, it will not penetrate this boundary. So it will have some dispersions just under this cap. And this is called fumigating plume. And again, we can use this method to analyze other situations. And for this fuming plume, when we have something like this, and this usually happens in the sunset. So when we have a layer, something like here. So if we have some smoke, it will not straight going up, it will just disperse at relatively low height to some other places. So this is very bad to our health. And so far, do you guys have any questions? Then let's talk about air pollution. So basically, air pollution refers to any visible or invisible particles or gas found in the air that is not part of the original normal composition. In other words, if we release nitrogen in the air, it is not considered as air pollutant. So similarly for oxygen. But we can say CO2 is included in air pollutants, although it is a composition, because if we have a large amount of CO2 in the atmosphere, the composition will change. So it will be very different from its normal composition. So CO2 is considered as an air pollutant. And I will talk more about CO2 later. And in terms of the air pollution, like when we have like many different typical air pollution events in history, and I think the most famous one should be the one that happens in London, which is called the Great Smoke. The Great Smoke, yeah. And this is caused by, do you guys remember which one? Which pollutant? In London? No idea? So that is caused by SO2. And I will talk this a little bit later. Okay, so, and then let's talk about the source of the air pollutant. The first one is like it can come from human, like all the humans are the main cause of the air pollution. And it can come from industry, including like the factories, power plants burn the large quantities of fuels. Also the burning coal and petroleum gas, petroleum released like SO2 and nitrogen oxide into the air. And it may also come from the airplane, boats, and cars like the vehicles or some transportation stuff. And again, this can release carbon monoxide and carbon dioxide in the atmosphere. And we can see like the smoke is very bad. But I think for nowadays, it is hard to see the smoke, something like this. And the next one is from the natural emission. So basically it could come from the wildfires, like something like this. When it is burning, we will have a large amount of smoke. And also the volcanic eruption is also another source of the air pollutant. So it will add, so it will release both the poisonous gas into the atmosphere, but it will also release the particulate matters in the atmosphere. And another source is the dust storm, which is very bad, and it will introduce the particles into the atmosphere. So that's why we need to grow more trees on this planet. And because of the air pollution in the United States, we have this Clean Air Act. So like the Congress designates the Clean Air Act to protect the public health and welfare from different types of air pollutants caused by a diverse array of pollutant source. And this is the cover of the Clean Air Act. And we can see this is implemented when I was young. And but this was enacted in 1970, and we can have some more detail. Oops. Okay. So I added this in the last semester, but I'm not sure why this is have some errors. Okay, anyway, I will update this link. And EPA requires to investigate the environmental and human effects of air pollutants emitted by stationary or mobile source. So basically, the mobile source mainly refers to the vehicles on the road. And because of this act, like for our environmental studies, we have some fundings to do this research. And in terms of the standards, I think the most commonly used one is the National Ambient Air Quality Standard. So I think this link should work. So this is a table of National Ambient Air Quality Standards. So basically, this is for outdoors. And in this standard, it has two types. And the first one is primary standards, which is designed to protect human health. And the next one is secondary standards. This is to prevent environmental and property damages. And based on these two standards, we would expect that for the human health, the standard will be more strict. Like the allowable concentration is expected to be lower than the secondary standard. Let's just see this table. Oh yeah, it's also describe the primary and secondary here. So from this table, we can see that we have this air pollutants that is regulated by EPA. And we can see we have this carbon monoxide, and it only has the primary, and we have the lead, nitrogen dioxide, ozone, particulate matter, and sulfur dioxide. And from this, we can see, let's just say this sulfur dioxide. It has a primary and secondary concentration. And we can see this is ppb and this is ppm. So we can see that the secondary concentration is larger than the primary concentration. And this is the same for PM2.5 or PM2.10. We can see that this secondary concentration is higher than the primary concentration. So if you are interested, you can just go to this link and find this table. And yeah, so these are the regulated air pollutants from this standard. So for this one, do you guys have any questions? No? Then let's just look at this one. So have you guys ever seen this one before? No? I think you should. How about you guys? No? So, yes, so this is a stove. So this one is called the Kowo, and this is invented by Japanese. And in Japanese, it is called the kneaded coal because they just dissolve the coal and then they reshape the coal into some specific shape because this is good for the ventilation. And in China, we call that the beehive coal because it looks like the beehive. And then we can put this coal into this stove. So it will be something like this. But I think for nowadays, like in China, it is hard to see this type of stoves. But maybe it was used in some remote areas. And based on the Wikipedia, I saw that this type of stove was very popular in Asia, but in other continents, it is not quite popular. So this stove have some problems, like it may cause some risk. So basically, we can see that, so this is the inlet. So for the inlet, we have the air, especially we have oxygen. And we know that this coal consists of carbon. So in the stove, when the air gets into this stove, we may have the reaction of the carbon will react with oxygen. So we will have carbon dioxide. And then because we have some channels in the probe, they can be released from here. But we can see if we do not have enough oxygen, like at the very beginning, we may have enough oxygen, but maybe in the middle or maybe at this top, we may not be able to have enough oxygen. So in this case, if the oxygen is limited, the carbon will also react with oxygen and it will form carbon monoxide, which will only have one oxygen here. On the other hand, at very high temperature, the carbon dioxide may react with the carbon itself to form carbon monoxide. So in this case, we can see that we may have some carbon monoxide from this stove if we do not have a good ventilation or the oxygen is relatively limited. So as far as I know, it caused many problems, like people get toxic, get this carbon monoxide in the room. They use this inside the room and then they die. So this is very bad. And the first air pollutant I want to be talking about is carbon monoxide. And this air pollutant is dangerous because it is an odorless and colorless gas. So under low concentrations, we cannot feel it by ourselves. And after being inhaled, carbon monoxide molecules can enter the bloodstream where they can inhibit the delivery of oxygen throughout the body. So we will die out because of lacking of oxygen. And low concentrations can cause like different adverse effects. So on the right side, it is a table of the adverse effects of carbon monoxide at different concentrations and at different exposure time. And the source is like, this is produced by incomplete burning of carbon-based fuels. So if we are lacking of oxygen, it is very possible to form carbon monoxide. And it is also produced from incomplete combustion of natural and synthetic products, like the cigarette smoke. So smoking is not healthy. And it can build up in high concentrations in enclosed area like the garage or poor ventilated channels, and even along the roadside in heavy traffic. So these places may be contaminated by carbon monoxide. So we should avoid staying in this place for a very long time. Another air pollutant is nitrogen oxide. Here I use oxide because it may be nitrogen oxide or nitrogen dioxide, and may also like some other numbers of oxygen. So for nitrogen oxide is a major contributor to the smoke and for the acid rain. So basically, when the nitrogen dioxide get into the air, it can combine the oxygen and combine the water. So it can form the nitric acid. And we know that the nitric acid is a strong acid. So when it is dissolved in the rain, it will become very acidic. And the acid rain can have some adverse effect to the vegetations and run into the lakes and rivers, which change the chemistry of the water and makes it potentially uninhabitable for all but acid tolerant bacteria. And we also talk about the acidity in previous lecture that if we decrease the pH of the lake or the soil, we know that the heavy metals will be more active, so which is more toxic for those environments. And for the nitrogen oxide, they can react with volatile organic compounds to form the smoke. So basically, the nitrogen dioxide, this is the gas with a brown color. So with more these chemicals formed, the air will become brown, so it looks like the smoke. And on the right side, it shows the effects of different nitrogen dioxide concentrations. And again, we can see that it can have a bunch of different adverse effects to humans. And the source, the nitrogen oxide are produced from burning fuels and including the gas or the coals. So basically, when we have the coal, we know that it mainly consists of hydrocarbon or carbon, but because the coals comes from the like the dead organisms. So the dead organisms, they may contain some nitrogen, or they may also contain some sulfur. So when we are burning this material, we may have the nitrogen oxides or the sulfur dioxide. And this paper shows the concentration of nitrogen dioxide in the United States here. And notice that this is 205 and this is 212, so which is about 10 years ago. And from this, we can see that the places that have relatively large concentration is around the east coast of United States. And I think the Maryland should be something like here. So when we have a relatively large amount of NO2 here. And yeah, we can see we also have something here. But in general, we can see that after about 7 years, the concentration of nitrogen dioxide like kind of decreases over time. So which means the air become better. And the next pollutant is ground level ozone. And the keyword is ground level. We know that ozone is very good in the top of the atmosphere because it can absorb the UV radiation from the sun. But the ground level ozone is bad. So the ground level ozone can irritate the respiration tract and it can cause different types of adverse effects. And ozone can also damage the trees and plants and reduce the visibility. So basically, in the atmosphere, ozone may form from the nitrogen dioxide and volatile organic compounds under the sunlight. So the sunlight can transform this into the ozone because the sunlight can break down these volatile organic compounds into different radicals, and these radicals can combine this stuff to form this ozone. But in the nighttime, we can see that they will have some reactions. So the ozone will be consumed. So in general, we would expect that we may have a greater or severe ozone contamination in the daytime. And for the source, like the ground level ozone comes from the breakdown of the volatile organic compounds found in the solvents. And it is also a product or reactions between chemicals that are produced by burning coals and these fossil fuels and chemical found in paints and hairsprays. So during the burning processes, we may also generate some of the ozones. And oxidation occurs readily during the hot weather because the hot weather usually have a relatively stronger sunlight. And vehicles and industries are the major source of the ground level ozone. And here is here's a picture of the spatial distribution of the ground level ozone. This is a biomodel, so they just use one model to do the spatial interpolation to estimate the ozone concentration, like at every place in the United States. So we can consider it as the ozone concentration. And we can see this shows the concentration of different years. And this shows the annual, this is summer, fall, winter, and spring. So let's just look at this in 2000. We can see that this is in summer, and this is in winter, and this in fall. We can see that the ozone concentration is much higher in summer than in winter and in fall. And it is also very high in spring. And I think this is making sense because in the summer or in the spring, when we have a greater sunlight. But in this case, we can also find that in winter, we have a greater concentration than in fall. I'm not sure why this happened. Maybe they discuss in this paper. I haven't read this thoroughly, but if you are interested, you can just take a look at this paper. And we can also see that the most contamination, or the places that has the greatest ozone contamination, is in the middle west of United States. And in terms of the Maryland, I think the ozone contamination or the concentration is okay. Yeah. The next one is sulfur dioxide. So, and it has some properties like it can narrow the airway and causing the wheezing and shortness of the breath, especially for those with asthma. So it has very bad adverse effect to human beings. And it can also damage the plants. On the right side, it shows the pictures of the plants that is exposed to sulfur dioxide. We can see they will lose their chromos. I don't know, like the one that is used for the photosynthesis. So if it is not green, it cannot do the photosynthesis, so they will die. And this is on pine. And again, the sulfur dioxide can also form acid rains. So basically, we have the sulfur that is burnt in the fossil fuel. We will form this sulfur dioxide. And the sulfur dioxide can react with the water in the atmosphere to form this acid. And in the atmosphere, we also have oxygen. So this one will react with oxygen to form the sulfuric acid. And this is a strong acid, so it can cause acid rain. And the sulfur dioxide produced when the coal or fuel oils are burnt. And it also presents in a power plant exhaust. And so far, do you guys have any questions? I didn't find the ground level or the atmospheric sulfur dioxide in the United States, so I didn't find the paper. But if you guys find, you can give it to me. And the next one is lead. Lead is considered as air pollutant because some forms of the lead has very large vapor pressure. For example, this one, this is tetraethyl lead. So we can see that it is surrounded by some organic groups. So basically, this one has relatively high vapor pressure, and we can also see that because it is organic, it is expected to have relatively large KOW. So it may also very easily get into human bodies or some other organisms. So for the property, lead is a highly toxic metal that produces a range of adverse effects, and especially for the young children. And lead can cause, like, again, different adverse effects, which I'm not going to read it. But it is not only bad for human beings, it is also bad for the wildlife. For the source, it has been phased out of gasoline. So basically, in history, we add lead, especially this tetraethyl lead, into the gas because it can make the engine run smoother. But when this stuff released in the environment and cause some of the problem, this was banned. And yes, so because of the ban, then it can reduce the contamination of lead. in the air. But the lead can also be still be inhaled or ingested from some other sources, like the other sources like from the paint, and it may also from the smelters, manufacture of lead batteries, fishing lures, and some certain parts of the bullets and ceramic ware and water pipes and some other stuffs. And this picture shows the lead pans like from an old house or something. And we can see that it may gradually release some of the lead powders in the air. If the powder or the particle is very small, it can be floating in the air and be inhaled by humans. So which is bad. And the next one is particulate matter. And so this is what my research is about. So particulate matter is called, PM is called particulate matter, and it refers to the particle of different sizes and structures that are released into the atmosphere. And it can absorb water, heavy metal, organic pollutants, and microorganisms. So basically, if we have a particulate matter, because it has its surface, it may absorb some of the water in the atmosphere. And we may also have some different heavy metal particles, and they can be absorbed on the surface of the particulate matter, as well as the organic pollutants, because it can absorb different chemicals, which may also include the nutrients. And because it has a nutrient, the microorganisms are very happy to stay on this surface because they have food. But when this particle is inhaled by human beings, then it will release this pollutant in the human body, which is bad. And because I'm doing this research, I just use a slide from one of my talk. So here is a source of the particulate matter. We can say it may come from the roads. We can say we have the particles suspended by here. Oops. And may also come from the factory that will release the particulate matter. It can come from the construction site, something like this. And again, the mining. And it may also come from some animal operation. Stuffs like the poultry house. Here shows the health. Before I want to talk about the health impacts, I want to talk about the classifications of the particulate matter. So mainly we may classify it into two categories. The first one is PM 2.5, which refers to the PM with an aerodynamic diameter less than or equal to 2.5 micrometer, and PM 10 is the diameter less or equal to 10 micrometer. And here the important word is aerodynamic diameter, because we know that the particle, they are not always a sphere. It can be something like this one, or like the plates, or like it has different geometrical structures. So we use the aerodynamic diameter, which means that as long as their behavior in the air or their behavior under some aerodynamic conditions are the same to a perfect sphere, we can consider them as the aerodynamically has the same size of this particle. And we can see that because this size is pretty small and much smaller than a human here, so it is very hard to observe these particles by human eyes. The size is very important because the particles of different sizes, they have different ability to penetrate the human bodies. I guess I opened the auto play translation. Okay, anyway, let me just like this. So from this picture, we can see that for the particles of different sizes, they can penetrate at different extent to the human body. PM 2.5 is important because for the particle size that is smaller than PM 2.5, they can penetrate this channel into the lungs. And we know that in lungs, we have a relatively very large area, and we have some interactions between the blood and the air. So this is, so the pollutants or the toxic chemicals, they can release directly into the human body. For the health impact, that again, the PM have different types of health impacts, and we can say most of them are related to the inhalation system. On the right side, it shows the PM2 concentration over United States. So again, let's also say it's the predicted concentration because they use different types of spatial interpolation methods. So this is the original observation, which is very similar to the spatial sampling lecture, and this is their interpolation result. So let's just focus on this plot here. So we can see that this is a PM 2.5 concentration. And we can see that in United States, the PM2 contamination is more severe in south east region. But we can also see that for this region, like it is something around California, something like here. It may also have some relatively high concentration in this region. And in Maryland, I think that is around here. So I think that is okay. And if we recall that the ambient, the ambient air regulatory standard for PM 2.5, I think that is 12 for the primary standard. And we can see that for most of the areas, we have like the concentration that is lower than this regulatory standards. And so far, do you guys have any questions? It's also due to the lighting. Oh, yes. Yeah, I didn't notice this chat. Yes, so for the NOx, I think the lightning. Oh, yeah. So for the lightning, we have the nitrogen gas in the air. And because of the lightning that has very strong energy, it will oxidize the nitrogen gas into the nitrogen oxide. But so this is one of the natural source of the air pollutant. Okay, the next one is carbon dioxide. So the carbon dioxide is a principal greenhouse gas emitted as the result of human activity. And it can cause like different adverse effects if the concentration is very high. And again, the high concentration of carbon dioxide can cause different adverse effects. But it can also cause the acidification of water bodies because we have learned that the carbon dioxide can react with water into carbonic acid and it can dissociate H+. And here on the right side, it shows some of the mechanisms of the greenhouse effect. So basically, we have the sun, it has a radiation to the earth and to the ground of the earth. But when the ground of the earth receive that energy, it will reflect the energy out. But the difference is that this is a short, this radiation has relatively short wavelengths, and this has a relatively long wavelength. And for the carbon dioxide, or the water vapor, they are very happy to receive the radiation that has long wavelengths. So the carbon dioxide or the water vapor, when they receive this radiation, they will increase the temperature. So the temperature of the atmosphere will increase. So a large amount of CO2 in the atmosphere will strongly increase the temperature in the atmosphere. So they are not quite good. And the next one is VOC, which is volatile organic compounds. So they are chemicals that evaporate into potentially harmful gases at room temperature. So, and may or may not exclude outdoors. And here are some examples of the volatile organic compounds. We can see that from this structure, they are small molecules. And intuitively, we can see that they have relatively large vapor pressure. And VOC includes a variety of chemicals which can cause like short-term or long-term health problems. On the right side, it just shows some of the health effects of the volatile organic compounds. But because the volatile organic compounds it may have different chemicals, so we may discuss the adverse effects case by case. And the last one is ammonia. I think we are very familiar with ammonia, so this is its chemical structure, and the ammonia in the air can react with water to form this ammonia. And in this reaction, we can see that the OH minus will generate. So if the air is contaminated by ammonia, then the water body will become basic. And because it can cause very basic water solution, it is corrosive, and this is also toxic. And it is also environmental toxic, especially for the fish. So the fishes are very sensitive to contamination of ammonia. On the other hand, ammonia in the atmosphere, it is a precursor of PM2.5. So in general, when in the atmosphere, like when react with some of the water drops in the atmosphere, we will have this ammonia. And for the ammonia, we know that it is positively charged. And also in these small water drops, we have this like the sulfuric acid, and we have this nitric acid in the water. When we have the neutralization reaction, but finally, we will have this salt. So it consists of ammonia and the sulfuric and the nitro, something like this. And then this is a crystal solid, and it can become larger and larger, and finally it will form PM2.5. And so far, do you guys have any questions? No? So that's the end of, so that's the last slide. And so this picture shows I didn't find the ground level ammonia concentration in the United States, but I find the emission of ammonia in the United States. So, and this plot is the on-road emission. So this is the emission of ammonia from the vehicles. And the next is also the on-road emission, but it's from a different source. And for the last one, it is the agricultural emission of ammonia. So let's just look at this two together. We can see that ammonia, and we know that the emission is usually positively correlated with the concentration. So we can see that in the United States, and the ammonia may come like a large portion of ammonia may come from the agricultural activity. And we can see that for the agricultural activity, we may have some areas that has relatively severe ammonia emission. On the other hand, for the on-road emission, I think these are some of the big cities which has relatively large ammonia emission. Yes, so that's it for today's class. And finally, I want to say that for the quiz 8 and quiz 9, it will do this Thursday. And for assignment 6, it will due on next Monday. And for assignment 7, it will due on next Thursday. And for this unit, for the air pollution unit, we do not have homework assignments, but we have a quiz, and the quiz is also due on next Thursday. Yeah, so that's it for today.